let's look at some trig equations that require factoring to solve. So, looking at our first one, we're going to say 4 sine squared x plus 4 equals 5. Now, you can actually solve this without factoring, but we're going to look at it from a factoring perspective. So, we're going to use the zero product property. Okay. So, if you remember, for this to work, we need to have it set equal to 0, and then we got to factor it out. So, I'm going to subtract 5 to both sides and get this thing set equal to 0. Okay, so I get 4 sine squared, oops, forgot my x in there, sine squared x minus 1 equals 0. Okay, so you can factor this as is just to make things hopefully a little easier to see. I'm going to use u substitution as the factoring. So what I'm going to do is I'm going to let u equal sine x. So everywhere I see a sine, I'm going to replace it with the u. So I'm going to get 4 u squared minus 1 equals 0. Okay. Then I'm going to go ahead and factor. Okay, so this is a difference of two squares. So I get 2u minus 1, 2u plus 1. Okay, so then I'll set these equal to 0. 2u minus 1 equals 0, 2u plus 1 equals 0. Add a 1 to both sides. Subtract a 1 to both sides for this one. Okay, and then I'll divide by 2. And u equals 1 half, and u equals negative 1 half. Okay, so now what I can do is, all right, so go back and resubstitute this back in. Okay, so what this tells me is, separate this out, I get sine x equals a half, and I get sine x equals negative a half. Those are my two answers. Okay, well, there's really more. Now I have to go to the unit circle and ask myself, basically, where is that? And that's everything that's over a 6, so it's going to be, so x is going to equal pi over 6, 5 pi over 6. Those are the ones that correspond to that top one. And then the bottom one is 7 pi over 6 and 11 pi over 6. Okay. So let's keep going here. Okay. Let's look at tangent theta sine theta minus 4 tangent theta equals negative 3 tangent theta. Okay. So I'm going to try to do a little bit I'm going to try to do this one without the u substitution so we can see if we can kind of follow along, and then we'll kind of go back and forth. So same thing, use the zero product property. So I got to get this thing set equal to 0. So I'm going to add a 3 tangent theta to both sides. Okay. So I get tangent theta sine theta. Oops, sorry. Minus a tangent theta equals 0, right? Because I had 4 negatives and 3 positive tangents. Okay. So now I'm going to look in this. I'm going to take a GCF out on this left-hand side. And then that equals 0. Okay. So then I'll set those equal to 0. So that one's already solved. 1 to both sides. Okay, and then I'm going to check my unit circle and find out where those particular values are true. So okay. All right, and then where's the tangent 0? That's where the y is 0, so that's 0 and pi. Okay, and then where is the sine 1? That's at pi over 2. Okay, so there is one little issue here. At pi over 2, which is this coordinate point right here, right? That's the coordinate point over 2. So the tangent is 1 over 0, so there is no tangent. And since I have a tangent here in my original answer, I have to ignore that particular solution. Okay, so it's just 0 and pi. All right, let's keep moving on here. Radical 3 secant theta plus secant theta cotangent theta equals 0. So this one is already set equal to 0. So that's nice. So all I'm going to do is look and see if there's any kind of factoring. And I can factor out a secant theta. All right. These with root 3 plus cotangent theta. Okay, set my secant theta equal to 0. And root 3 plus cotangent. And then I can subtract that to both sides. Okay. And I'm left with cotangent theta equals negative root 3. And I could look at it that way, but I like to I'd rather change it to tangent. And remember, that's going to be the reciprocal, so it's going to be this. And if I rationalize it, it's going to be that. Okay. So the secant cannot be 0. So we can ignore that one. And then we're just going to look at tangent. Where is tangent equal to negative root 3 over 3? And that's 5 pi over 6 and 11 pi over 6. Okay. There's our answers right there. Okay. All right, let's do 2 more here. So let's look at 3 sine theta plus 2 sine squared theta equals negative 1. So same thing, get it set equal to 0. So I'm going to add 1 to both sides. And I'm going to get 3 sine squared plus 2, 3 sine, 2 sine squared theta plus 1. All right, and then I'm going to go ahead and do u substitution here just to make it a little easier on myself. So I'm going to do 3u plus 2u squared plus 1 equals 0. And then hopefully you'll notice that I have a trinomial, so I'm going to write it in descending order of power so it's kind of used to the way that I'm used to looking at it. And then I'm going to factor this thing. Okay. So I got to ask myself, okay. Well, the good thing is there's only one way to multiply to that number and one way to multiply to that number. So I know what numbers are there. Alright, I just gotta check pause. Everything's plus, so it's just gonna be like this. Okay. So now I gotta set those equal to 0. Then I'll solve them. Subtract 1 to both sides. Divide by 2. Alright. So I get u equals negative 1/2 and u equals negative 1. I'm going to resub back in. So I'm going to say sine theta equals negative 1/2 and sine theta equals negative 1. Okay, and I'll put my answers in. So this is 3 pi over 2. And then where is sine negative 1/2? That's in quadrants 3 and 4. So that's 7 pi over 6 and 11 pi over 6. All right, let's do one more here, and this one will require a trig identity. Sine squared x plus 2 minus cosine squared, these are theta, sorry, equals 3 sine theta. Okay, so looking at this, we have to get this thing set equal to 0. Okay, so what I'm going to do is I'm going to subtract 3 sine. I actually have a few options for what I'm starting with. I just decided to do that. So I'm going to get sine squared theta minus 3 sine theta plus 2 minus cosine squared theta equals 0. Okay, so this is definitely not going to factor. And the big issue is I have the sines and cosines in the same problem. You guys see that? I know there's a lot of writing on there, but so I need to get rid of one or the other, or I need to convert it using my Pythagorean identity. So I have a sine squared, a sine, and a cosine squared. So it's easy to change the squareds, right? So that sine is going to be hard to get rid of. And I already have a sine, so I'm going to turn everything into sines. So what I'm going to do is this. Just rewriting this. And instead of, I put the negative there, I'm going to replace this with that. Okay. So cosine squared is the same as 1 minus sine squared. Then I'm going to go ahead and do okay. So I distributed that negative in there. That's the part that's really tricky for people. Then I'm going to combine like terms. So I have 2 sine squared theta, right? Because I got 1 right there, 1 in the front, minus 3 sine theta. And then this is a positive 2 and a negative 1. I know that's kind of hard to see, and that all equals 0. Right? So just plus 2 and minus 1. Right? Then I'm going to go ahead and do use substitution to help myself in the factoring. You don't have to, but at first it's kind of nice. So, okay. So think of all the ways to multiply to that first term, and think of all the ways to multiply to the back term. So it's got to be a 1, but they come out to a negative, right? They add to a negative and multiply to positive, so that's only true when they're both negative. Okay. Then I can set those equal to 0. It's going to be u equals a half and u equals 1. Okay. So then I got to go back and resubstitute in. So sine theta equals a half and sine theta equals 1. So I can go ahead and put both my answers in there. So where is sine equal to 1? That's pi over 2 or 90 degrees. And where is it equal to a half? That's quadrants 1 and 2. And so that one would be pi over 6.